Radical equations and problem solving. One of the big concepts for this section is the Pythagorean theorem. What the Pythagorean theorem states is, can't even say it, Pythagorean theorem. For a right triangle, we can use the Pythagorean theorem to find missing sides. What it says is, the sums of the squares of the legs is equal to the square of the hypotenuse. The legs are the shorter sides. They're the ones connected to the right angle. We use A and B to denote the legs. Doesn't matter which one is A, which one is B. The most important item is that the longest side, the hypotenuse, is always C. So in symbolic notation, that would be A squared plus B squared equals C squared, or C squared equals A squared plus B squared. I like to write it as ABC because that's how I was taught my alphabet, so that's why I do it that way. Let's do a quick example using a drawing. We're going to find X, or actually let's just call it C. Find C. Going to draw a right triangle. I'm going to use nice numbers, 3, 4, and C for the missing side. Let's just say that these are in centimeters. Now all we're going to do, since this is a right triangle, we're looking for the missing side. Let's use A squared plus B squared equals C squared, the Pythagorean theorem. It does not matter which one is A or B, so if you want to call A 3, that's fine. Do not forget the square. Then B would be 4, and C is our unknown side. And then by the order of operations, exponents first. 3 squared is 9, 4 squared is 16. Just bringing down the C squared as we go. 9 plus 16 is 25. And then we come to a place where some people think we stop, but no, we don't. We want C by itself. In order to get C by itself, we need to get rid of that square. And one way to do that is square root. And once you do the one side, you do the other. Now there's more to this that you'll learn in other classes. Just recognize this. Since we're finding the missing side of a right triangle, we must have a positive value. So that's all I'm going to say about that. What happens is this square and the square root cancel one another out, leaving C. And the square root of 25 is 5. Now I do leave out the units as I do the work, but keep in mind you want to include the units in your final answer. Now let's look at this example. Some people think, it's the same. It's not. I'm going to draw a right triangle. It says one leg is 3 meters, and it says the hypotenuse is 6 meters. It's a big deal to know what these words mean. The hypotenuse is the longest side. It's always opposite the right angle. This side is 6. Now let's just call this one A. I would use B, but my B's look too much like 6's, so I'm going to use the A. Since this is a right triangle, keywords, right triangle, I can use the Pythagorean theorem. Throw in our values. A is our unknown, B is going to be our 3, and C is 6. Do exponents first. Now this is where it differs from the previous example. We're trying to get the A squared by itself, which means we need to move the A over there or eliminate the A by subtracting. And we get A squared equals 36 minus 9 is 27. And then we're going to square root to get A equals the square root of 27. Now I'm going to show you two different possible answers that you may be asked for. One answer may be the exact value, or to simplify it. What that means is you want to simplify the radical. 27 is the same as 9 times 3. I use 9 because it's a perfect square factor. And the square root of 9 comes out as a 3, and this 3 stays underneath. Now that's one possible answer it may ask for. Another thing is it may ask you for the approximation, and so in that case all you would have to do is type it in your calculator. I'm going to use the graphing calculator for this one. Second square root 27, enter. Let's go 3 places, 5.196. And so that's the approximation. And don't forget, meters. And just in case, some of the scientific people, I'm going to take the 27, you turn it on first, 27 square root. See that? Hey, a little side note, this right here, we better get the same decimal. Let's see if we can. Let's find the square root first, and let's time that. That means multiplication. Let's times that by 3. See that? Either way you want to do it. Now let's do another example. This one is pretty much knowing what the variables represent. I'm going to have to tell you what these are because I didn't specify it in the problem, so I'm going to now. V is velocity, and the only other thing you need to worry about is h is the height from which an object is dropped. It's kind of a way to think of it. And so if you look, it has to find v using this formula for an object that's fallen 20 feet. That tells me that that 20 represents the h. If g is 32, g is that involves gravity. And so let's throw in the numbers. Notice when I substitute, I'll use parentheses. I'm a big fan of parentheses. And then all you have to do is take out your calculator. Now I'm going to do it with the graphing calculator first, just to show you all we're really doing, the advantages of having a graphing calculator or a scientific that allows you to do this. I'm going to type in the square root key first, and then I'm going to type it in like this: 2 times 32 times 20 close, because I want to make sure that all 3 of these numbers are under the square root, and this is one way to do it. And then enter. I'm going to round off 35.78. And then it could be whatever the units may be, feet per something. Now at the scientific, what you want to do is do the work under the radical first. 2 times 32 times 20 gives you that, and then the square root. See that? Either way is fine. Doesn't matter which calculator that you use.